Hello friends, today we're going to study the case study with respect to making of a solar financial modeling sheet using Excel. So till now we have studied about all the input parameters and the output parameters required for doing creating a financial modeling for a solar project. Okay, now we will going to implement that parameters and actually we're going to make a financial modeling sheet. Now the tool we're going to use for creating financial modeling sheets is Excel sheet. Okay, this is the recommended tool used by companies to do the financial modelings and doing its analysis. After creating this sheet, we're going to do the analysis. So first I will give you a quick demonstration what we're going to do. First of all, we will going to learn about how to create these kind of sheets. Okay, so first is our main sheet, that is the financial modeling sheet, and where you can able to see number of tables and including all the parameters which we have studied, right? Secondly are the related sheets. The first related sheet is the calculation sheet for calculating LCOE, and second is the sheet for calculating operation and maintenance costing of a solar project. Third sheet is the calculation of the loan payments, and fourth thing is the finally doing the sheet for doing the analysis. Whatever we have done in the previous four sheets, we're going to do the analysis on it and come to a conclusion with respect to a particular investment like solar projects. Okay, so let's start with the main sheet, that is that is also called as FM sheet in short, that is financial modeling sheet. Now we're going to see first of all how these sheets are created, and after learning each things in all the four sheets, and then we're going to implement the parameters for a case study of 1 megawatt solar power plant grid type. Okay, so we're going to see a case study on 1 megawatt size solar power plant, and the type of the solar power plant is grid tied. Why grid tied solar power plant we are only taking here? Because the major market outside in the solar field is on grid tied solar power plants. Okay, so and when we see large scale solar power plants, so they are only grid tied solar power plants only. So it is very much essential to make financial modeling sheets and to understand about the investment parameters, or how fruitful will be our investment in doing in putting money in large scale solar power plants. Okay, so we're going to see a case study on the major major segment in the solar market, right? This doesn't mean that smaller scale or medium scale or off-grid or hybrid solar power plant you can't able to do the financial modeling. Financial modeling can be done with every kind of investment, whether it is small, medium or large, using the same modeling input and output parameters which we have studied. But in this course we're going to see if you can able to learn the financial modeling of large scale power plants, then for the smaller scale and medium scale you can automatically very easily you can able to do it. Okay, so we're going to see the larger segment financial modeling. Okay. First we're going to see how these sheets are created. So first sheet is called as the main sheet, called as solar financial modeling sheet, and we're going to learn how these sheets are created. So here we can first of all, the first thing that you can able to see is the notes making. Okay, for every sheet you have to develop some kind of note, so that any user, if they are using these sheets, he can able to utilize these sheets by reading the notes effectively and avoid mistakes, and also it avoid wastage of time, right? So first kind of colors, yellow, red, and green, show something. Yellow color always means that you have to put some, you have to enter input parameters. Okay, from below. Okay, so here you can see we have our input parameter table and yellow color cells. Here we have to put the parameters what is asked by use of our keyboard, and once you are ready with the parameters, automatically in this particular output parameter sheets all the things will be displayed, calculated, okay, by the use of the internal Excel formulas, okay, which we are going to set up. Now the red color means the cash flows going out, means it can be the investment. So you must be checking the some figures in red color, right? So basically this red color means here right now just concentrate on don't concentrate on this revenue right now. I will clear why red color is shown under this revenue, but concentrate here. The red color should means that cash should flow out, and it can be the investment, right, or it can be a particular kind of payment, right, or particular kind of expenses, right, through which that means that cash is flowing out. Green color means that cash is cash inflow, right, means that all the green cells, all whatever number that will display after showing the results in the output parameters, that generally means that means that the kind of a revenues or profits, right? So these are the color indications that are very important. Next note is choose the country currency first before calculations, okay, by going to the format menu and going to the number and go to here more formats and more currencies, okay. So whatever currency you like to display it in this Excel sheet as per your country currency or required currency, or where the plant has to be installed in that country. So country currency, you have to show the number in a particular currency, right? So multiple country currencies are shown, so you have to select one currency and select one cell also, and then just like if for Indian rupees, and then I have applied, okay, now it is selected, okay. But one more thing is before select, so you have to select a cell first, okay, then go to the format column, okay. So in whichever cell you want to show the currency, okay, number in the currency, right, so that cell has to be selected first. For example, let's suppose loan amount from bank. So this is a financial amount that will going to come here. So I want to show this amount in let's suppose dollars, okay. So I have to select this cell first and then go to the format number and then more currencies, okay, more formats, more currencies, and click here US dollars and apply, okay. So whatever number I will type first, it will be shown in dollars, right, just like this, right. So if you can do this thing for single cell, or if you want to do this thing for a multiple cell, just like here, let's suppose for example, I'm saying that if you want to show the same thing in in this cell also, investment required, okay, it should be a financial money number. So I'm selecting this cell, okay, and I'm again going to the format section and here, and then now US dollar is directly showing, so I will click US dollar, okay. So one, okay, like this, okay. So you can do for multiple cells also, whatever cells you want to do, okay. So this is the thing that the second node is showing you to select the currency transfer, then start the calculation, okay. So it will be more beneficial and effective to see this financial modeling sheet. Now enter solar power plant capacity in kilowatt. So whatever capacity in this particular column, we're going to enter of the solar power plant for which we want to install, which we want to do the financial modeling sheet, okay. So the capacity should be shown in kilowatt, okay. These are the units, okay, of the solar power plant capacity. Now let's suppose our capacity is in megawatt or gigawatt, so please use these conversions which is shown. 1 gigawatt is equal to 1000 megawatt, and 1 megawatt is 1000 kilowatt, 1 kilowatt is 1000 watt. So this will helps you to convert a particular figure shown in megawatt or gigawatt in kilowatt, okay. So always remember this thing, Now, the last note is please update the sheet with respect to any new parameter which you will experience in future while progressing further in your career in the financial modelings. So with time we have to update our existing financial modeling sheets to get best effective results in future also, right? So upgradations of the existing parameter or addition of the new parameter you can also do in this financial modeling sheet, so that in future whatever new parameters you are going to learn or experience you can include in that if it is not there, or if you want to do the addition of any new parameters by discovering it or by experience, you can add this and you can make your financial modeling sheet much more effective, right? Now let's start creation learn how to create the input parameter table first of all. So this input parameter are all those parameters which we have learned in the previous lecture videos of our course. And what are these parameters? See here. So just make some rows like the country. Make a rows which should display that what to enter. Then make a column which will display what to enter, like country, state, currency, solar plant type, solar power plant capacity, annual solar days, like this. And then make a column where a user can able to enter a particular value with respect to what is asked. And then this column is showing whatever value you have to enter, that value should be in a particular unit. Okay, so let's suppose here in IRN I have written. So once I select a particular currency from the format menu, I have to also change this to whatever currency. If I want to change this, if I use it dollar, so I have to write it here dollar, right? Okay, so just like this INR was written because just as a default case. Okay, or we can write it here as a general that you have to write a correct currency as required, right? This looks much more effective. And then the last column is a remarks column to help the user what to enter and where to get the values, okay, information. Okay, so this looks a very good input sheet, input table for doing the input parameters, for doing the for getting the output parameters, right? I'm going to understand one by one of each row. Country means you have to write the name of the country in which solar power plant has to be installed. State, about the installation site. Currency, what currency you are going to choose as per your requirement, or the particular country currency where solar power plant is going to install. You have to select it by using format and write it here. Then solar power plant type, it can be grid tied, it can be off grid, it can be hybrid power plant, right? Here, just like this. Okay, but majorly we're going to see the largest scale segment in this financial modeling case study, that is a grid tied solar power plant. So we're going to write grid tied. Now capacity, it should be in kilowatt. Let's suppose 1 megawatt we're talking about. So 1 megawatt is actually how much kilowatt? It is 1000 kilowatts. So we're going to write 1000, right? So from where we have referenced this? We have referenced this by this conversion figures. 1 megawatt is 1000 kilowatt, like this. If you have 2 megawatt, 3 megawatt, you have to multiply by only 1000, right? Just like, and also if you have 1 gigawatt, 2 gigawatt, you have to multiply and you have to convert in kilowatt. So you have to multiply for converting 1 gigawatt into 1 kilowatt. You have to multiply by 1 to the 10 to the raised to power 6, right? Means 1000 to 1000, right? By this conversion table. Okay, so always refer this conversion table for your own help, right? Then the next is that enter total number of annual solar days in that particular country where solar power plant has to be installed. Now you have to get this data from a recommended source or trusted data source, like you can go to the NASA website, and especially for India there is a ministry called as MNRE, Ministry for New and Renewable Energy, which is promoting renewable energy in India in a very good manner, right? So you can go to this website and you can get to know how in India how much there are exact solar days or sunny days, we can say. So similarly for any kind of foreign countries, you can go to this website, okay, and you take the data and enter it here. So let's suppose in India almost 320 days are sunny days or solar days out of 365 days. Okay, so I will be entering like this here 320, right? Just like this. Now Next is average electrical energy productions per kilowatt per day, and just here you have to enter. What will be the possible electrical energy productions that will going to come from the solar power plant every day per kilowatt. Okay, let's suppose we are installing 1 megawatt, means 1000 kilowatt. So from every kilowatt of that 1000 kilowatt, how much electrical energy that can be produced every single day. Okay, so that data. Okay, so its unit should be in kWh per kilowatt per day. Okay, now this data, for this getting this data, you have to contact the solar designing department of the particular solar EPC company in which you are working, right? For which you are creating this financial modeling sheet, right? So financial modeling is something in which you have to come in contact with the other technical departments. Okay, costing department, designing department. Okay, project department. Okay, installation department, or operation maintenance department. Okay, and also the costing and the accounts department also, right? So you can be a person working in a particular financial or costing department or marketing department. Okay, whose responsibility is to create and your responsibility is to create a financial model for this. So you have to work in a team to get the informations for your financial modeling sheet. Okay, so in this way only you can get the accurate data figures. Okay, please do not take the figures which are not coming from a trusted source, or you are simply doing the calculations on your own but without referring anybody, right? So it will lead to a wrong calculations, wrong financial modeling data. Okay, so here it is written that company solar design department, and that department will give you a PVSS report, and in that report this particular figure you are going to get. Okay, annual average electrical energy production per kilowatt per day. Okay, and if you have any problem in studying that report, then you can directly ask this figure from that any concerned person who is generating this PVSS report. Now this PVSS report is generated by a software called as PVSS software, which is a solar simulation software, so for use for solar project to generate a very effective kind of technical reports. Okay, so in the previous lecture video we have shown the PVSS report sample for your understanding. Please go through the previous lecture video if you have any queries. Then next thing is you have to enter PPA time period. What is PPA? PPA is basically power purchase agreement that need to be signed between the solar EPC company and the client. The client can be a particular government client or a particular private client, right? So PPA time period means for how much time duration this PPA agreement will be effective. Okay, so it is actually the life cycle of the complete operation of the solar power plant. Okay, so you have to enter it here, and by taking the data source from the PPA agreement which is going to be signed, or it is already signed. Okay, so like for example it is almost around 15 years to 20 years. Okay, in large scale solar power plant case. Now investment required is a total capital required for this power plant to do the for its power plant to do the complete designing, procurement, construction, commissioning, everything, so that power plant will become operative. Okay, so the entire capital cost that is required. So this figure you can get from the company's costing department very effectively. Okay, now financial categories. So for this capital to get what financing strategy your company is going to do. Okay, so as we have studied, there are two major categories. One is called as domestic financing. Either you are doing either you are taking loans from domestic bank or from international financial institutions or banks. Okay, so you have to write either domestic or international as per your case, and then also financing subcategories type, that is in this particular subcategory you have to write either your financing is going to be a corporate financing or project financing. So what is corporate financing? Project financing we have very clearly explained in the previous lecture video of financing. Please refer it if you have any queries. We have to write in this column either corporate or finance as per the case. Then what is the loan amount that will going to be sanctioned or passed from the bank. So this data we have to actually, here in this field we have to enter the percentage amount of the loan sanctioning. Okay, so data source can be, this particular thing data has to be, you can get the data from the bank from where the loan is applied, and the bank, and bank has passed the loan, and by checking the company credentials, financial credentials, and other appraisals, and also it can be a non-banking financial institutions. Okay, like in India, one of the non-banking financial institutions is IRDA. Okay, IRADA. Okay, you can go to the website of IRDA and you can have the information. Okay, what is the interest rate that is offered by the IRDA. And we have also seen our in the chapter lecture video of financing in the previous videos. What are the banks and what are the interest rate available in India, and also what are the non-banking financial institutions in India and abroad. Okay, so both of the scenarios for India and abroad we have presented in the previous lecture video of financing chapter. So please refer it if you have any queries. So we have to enter here what is our loan amount sanctioned from the bank. Okay, after all the formalities is completed, then we have to enter here the exact loan amount, and then the interest rate also bank will going to give you, enter it here, and whatever remaining, if 100% financing is not taking place, then 100% debt financing is not taking place from the bank, then obviously equity amount will be required. That means whatever the difference amount that is needed, that for example, let's suppose bank is sanctioned 90% amount of the total capital required, so 10% is the equity that has to be invested by the investors of that company. So that amount we have to write it here. Then the next field will be year of completion of SPV solar power plant, in which year solar power plant complete installation commissioning will takes place. So we have to get this year figure from the company's project management department. Okay, and what should be the first year of operation of the solar power plant. So that figure also you have to get from the company's project management department. The last figure is the earning from the carbon credits. Carbon credits is actually kind of a thing by the help of which a particular solar power company can get the earnings or financials, okay, during the complete operation of the project. So for getting the carbon credits and earnings from the carbon credits, the particular solar power project by the company has to be registered under the Clean Development Mechanism, in short CDM, scheme of which is led by UNFCCC, okay, United Nations Framework on Climate Control, right? So you can go to the website of UNFCCC and you can know the formalities and procedure to register a particular solar power project to get the carbon credits, and how to and for getting the earnings, how to trade this carbon credits. Okay, so we have explained what is carbon credit and what are the related things about that in the chapter video of carbon credits. Please refer it if you have any queries. Okay, so till now all the input parameters is entered, and our input sheet is ready to use. Okay, so this is the way to create, so we have to create this input sheet. Okay, so Excel knowledge is very much required. A basic kind of Excel knowledge you have to get, means how to write in the Excel sheet, how to use the cells, okay, how to give this colors, okay, and how to give the links. Okay, so data is there, and you have to only create the sheets by same data by having a certain knowledge of Excel sheets. So if you don't know how to use Excel sheets, so I will request you to first know a basic know-how of the Excel sheets, and then coming back on this, and then create Excel sheet financial modeling Excel sheet for your own. Okay, so this is how what should be the notes, and how input parameter sheet is created using Excel sheets. In the next lecture video, we're going to see the further stage of the output parameter sheets, how Hello friends. Now in the previous lecture video we have seen how to create the input parameters table just like this. Now we're going to discuss the next step, that is creation of the PPA rate row. So this is something which is automatically calculated. This should be automatically calculated from the LCOE sheet. Okay, so LCOE sheet is basically a sheet in which the levelized cost of energy, that is the cost of per unit energy that will be generated from the power plant and sold to the client. It will be calculated and it will be taken as the rate of tariff in the PPA. Okay, so we can also write it here. We have to make a row and we can say it is the PPA tariff rate, okay, which has to be shown here. Now so here the data source LCOH list, and we have to set this particular row in a way that automatically from the LCOH sheet the value should be taken from there to here, okay, by the Excel. Okay, how? So we have to create this first just like this, and then we have to also create LCOE sheet. Now we're going to discuss the LCOE sheet. I will just zoom in some slightly so that all the total view of the LCOE sheet should be displayed very correctly. Now this is a additional sheet or supporting sheet to FM sheet for calculating the LCOE, that is levelized cost of energy. Similarly, as per the FM sheet, we also should have some notes here also. Yellow color means the input parameters. Yes, choose the currency first. Current currency first as per required. Now the energy production should be decremented yearly as per the solar panel performance degradation rate yearly. Okay, it is specified the data source you can take from the solar panel technical sheet. So what is this thing actually? What happens that once solar power plants start working, from the first year operation till the entire life cycle of the solar power plant, every year there is a degradation of there is a degradation in the performance of the solar panel. Okay, so for example, whatever energy the solar panel total energy solar panel will give you in the first year of operation, in the second year there will be some degradation, in the third year there will be some degradation. Okay, this degradation is not very too huge, but it is a very slightly degradation, almost around 1%. Okay, so this value you should always so what is the value? Okay, it is something sometimes with good brand of solar panels this value is also very small and less than 1 also, and sometimes slightly greater than 1 also. Okay, so we need to very accurately check this value from the solar panel technical sheet. Now when you once so you can you can connect with the company's procurement department and you can take the technical sheet from there. Okay, because they are the persons